Hello everyone, I'm Arzu from Chanakya Tutorial, where we believe that your goals are ours. In today's class, we'll be covering chapter Chemical Reactions and Equations, and the whole chapter will be revised in this single video. So let's get started. Chemical Reactions and Equations. For example, if milk is left at room temperature, it turns into curd. A pan which is left exposed in the atmosphere, it rusts. We make wine from grapes through the method of fermentation. We cook food at a home or the process of digestion that's happening in our body every day. The process of respiration. What are all these? Here, the initial substance has changed. That is, a chemical change has occurred. That is, a chemical reaction has taken place. For example, if we say this activity, where we take a magnesium ribbon, we hold it with pair of tongs, and then we burn the magnesium ribbon. We collect the ash, which is magnesium oxide. So we see that a reaction has taken place when magnesium ribbon burns with dazzling white flame and it changes into this white powder, magnesium oxide. So a reaction has taken place between magnesium, the oxygen present in the atmosphere, to form magnesium oxide as the product. Now we'll see another example where we take lead nitrate solution in the test tube and we also make a potassium iodide solution. We add the potassium iodide solution into the lead nitrate solution. What we observe that a yellow color precipitate has been formed. Next activity we see in a conical flask we'll add some zinc granules. That is, we are adding metal zinc. We'll add dilute H2SO4, that is this dilute acid, to the zinc granules. What happens when we add dilute acid to the metal? There is release of hydrogen gas. Hydrogen gas has been released. So in this reaction, there is release of hydrogen gas and there is change of temperature, because if we'll hold this conical flask, it will be somewhat hot. That indicates that there is change in temperature. There is also change in state because initially there was no gas. We added solid zinc and the liquid dilute H2SO4, but we saw release of hydrogen gas. Hence, there is change of state also. So, we saw these three examples. What happened in this example? There was change in state. For example, there was change in color, yellow precipitate formation. There was evolution of gas, for example, hydrogen gas. There was change in temperature because the conical flask became hot. There was formation of yellow precipitate. So all these were example of chemical reaction. So again, we see that during chemical reaction, there can be change in state. There can be change in color. There can be evolution of gas. There can be change in temperature. Or there can be formation of precipitate. Now we'll see the valency chart. That is, what valency chloride has, what valency bromide has, what valency iodide has. So they all have 1 as the valency. That is, either they need 1 electron to gain the noble gas configuration, or they want to lose 1 electron to gain noble gas configuration. Similarly, these are the examples where valency is 2. So for example, if we say chloride, bromide, iodide, hydrogen and potassium, they have valency 1, while zinc, magnesium, calcium, oxygen, sulfate, they all have valency 2. Then we have some other examples where there is variable valency. That is, for example, copper can exist in either valency 1 or valency 2. That is copper positive or copper 2 positive. Similarly, iron can be in Fe2 plus or Fe3 plus. Aluminium have fixed valency, that is 3. Now we'll see what are chemical equations. First of all, we'll see what is a word equation. We simply write the equation in form of words. For example, magnesium will react with oxygen to give magnesium oxide. On left hand side, we are writing reactants. On right hand side, we are writing products. And this arrow indicates in which direction the reaction is moving and what is formed as product. What is the yield in the reaction? So this arrow indicates that. So this is an example of word equation. Now what is chemical equation? It is a short form of the equation we have written before. In this, we'll write symbol for that metal. For example, magnesium will write Mg. It will react with O2 to give MgO. So instead of writing whole magnesium, oxygen or magnesium oxide, we'll write their symbols, that is magnesium plus O2 changes to MgO. Where on left hand side, there are reactants. On right hand side, there are products. And the arrow indicates direction of the reaction and the yield. So if the number of, it should be noted that the number of atoms of each element, for example, for magnesium, on the both sides is same. Magnesium on the left side is equal to magnesium on the right side. And oxygen on the left side and oxygen on the right side. They have to be equal. Then only it will be called a balanced chemical equation. Else the equation is unbalanced, or it is also known as skeletal chemical equation. So the equation we have Mg plus O2 changing to MgO. It has 1 Mg on the left side, 1 Mg on the product side. Then we have 2 O2 on the left side, but only one oxygen on, we have 2 oxygen molecules on the left side and 1 oxygen molecule on the right side. That is, the equation is not balanced. Hence, it is a skeletal chemical equation. So, how we'll write a chemical equation? First of all, we'll write reactants. We'll write products. Reactants are written on the left-hand side. Products are written on the right-hand side. Reactants and products are separated by a, what will come here? An arrow, which indicates the direction of the reaction. When we have 2 or more reactants or 2 or more products, for example, here we have 2 reactants, magnesium and oxygen. Then how they will be separated? What will come here? The plus sign. Where we'll mention the condition of the reaction, that either we are heating the reaction or we are putting light in the reaction. So all of that conditions will come on arrow. Then we can also write the physical states of the reactants and products to make them more informative. For example, this S written in bracket indicates that magnesium is in solid form. This G written in bracket indicates that oxygen is in gaseous form. The product MgO is in solid form. So, to make the reaction more informative, we can write the state of the reaction in this bracket form. Now, how to balance the chemical equations? First of all, why we need to balance the chemical equation? We'll have to follow the law of conservation of mass. That is, mass can neither be created nor be destroyed. So, the total mass of the elements on the left-hand side should be equal to the mass of elements on the right-hand side. For example, on left-hand side, it is mass of A plus mass of B. It should be equal to mass of AB. Now we'll see this example. We'll add zinc to sulfuric acid and we'll get zinc sulfate and hydrogen as product. We write the chemical equation as Zn plus H2SO4 changing into ZnSO4 plus H2. To balance the chemical equation, first of all, we'll write which elements are present. For example, zinc is present. So we'll write zinc. What are the number of atoms present on the left side of the zinc? There are 1. On right hand side, how many zinc atoms are present? 1. Similarly, if we'll write for hydrogen, there are 2 hydrogen on the left hand side. Similarly, there are 2 hydrogen on the right hand side. Now, if we'll go for sulfur, there is 1 sulfur on the left hand side and 1 sulfur on the right hand side. Now, if we'll see for oxygen, there are 4 oxygen on the left hand side and 4 oxygen on the right hand side. So, as per law of conservation of mass, the number of atoms of element is same on the both sides of the arrow. So all are equal. Number of atoms of zinc, hydrogen, sulfur or oxygen are equal on left hand side and right hand side. Hence, it is a balanced chemical equation. So what will be the process of balancing a chemical equation? For example, if we take Fe plus H2O changing into Fe3O4 plus H2O, H2. We'll list the number of atoms of different elements. For example, the elements Fe, the number of atoms on the left hand side, number of atoms on the right hand side. Then hydrogen, and then oxygen. So we see the number of atoms on the left hand side of oxygen is 1, while it is 4 on the right hand side. For Fe, it is 1 on the left hand side and 3 on the right hand side. Hence, it is not balanced chemical equation. It is an unbalanced chemical equation. So first of all, we'll take which compound? The compound that contains maximum number of atoms. We'll choose this compound and we'll start balancing from this compound. For example, here only 1 atom is present, here 3 atoms are present, here 7 atoms are present in this compound. So we'll choose the compound with maximum number of atoms. In this compound, we'll take oxygen. For example, we have 1 oxygen on the left hand side and 4 oxygen in the right hand side. To balance, we'll have to multiply 4 on the left hand side. Then only 1 will change into 4, right? So what we'll do, we'll add 4 as coefficient to H2O. We'll not change the formula to H2O4 or H2O4 for changing 1 O to 4. We cannot change the formula. Formula of water will be H2O only. We can only multiply it with a coefficient. That is, we can either take 4 molecules of H2O, 3 molecules of H2O, but we will not change the formula of H2O. Hence, we can write it as coefficient 4. That is, we have multiplied it by 4. So the number of oxygen on the left hand side has also become 4. Next, we'll balance hydrogen. How many hydrogen on the left hand side? 4 to the 8. But how many hydrogen on the right hand side? Only 2. So to balance, we'll have to multiply what number on the right hand side to hydrogen? 4. So we'll write 4 as coefficient of H2. So hydrogen is balanced and oxygen is balanced. What else is left? Iron. Initially, we see 1 Fe on the left hand side, 3 Fe on the right hand side. We'll multiply 3 on the left hand side and the equation becomes this, where we have equal number of elements of Fe on the left hand side and equal number of elements of the Fe on the right hand side. So this method of balancing chemical equation is known as hit and trial method. We can also mention the physical state of the reactant and product. For example, we have seen how to represent gas as G, small g in bracket. For solid, small s in bracket. For liquid, small l in bracket. And for aqueous solutions, AQ in bracket. So we can write the final balanced chemical equation as 3Fe solid plus 4H2O gas changing into Fe3O4 solid plus 4H2 gas. Similarly, so we can also mention what are the conditions of the reaction, that at what temperature we are or what pressure or what catalyst we are taking in the reaction. They all can be indicated above the arrow. For example, CO gas plus 2H2 gas at 340 atmospheric pressure changing into CH3O4 liquid. Similarly, this reaction where 6CO2 aqueous plus 12H2O liquid in presence of sunlight and chlorophyll changes to C6H12O6 aqueous plus 6O2 aqueous plus 6H2O liquid. So this is a very famous and must be a familiar reaction for you. This is the photosynthesis reaction, right? Now we'll study types of chemical reactions. What happens during chemical reaction? That we have seen the atoms of one element on the left hand side is equal to the atoms of element on the right hand side. They do not change. For example, oxygen doesn't change into fluorine. If there is oxygen on the left hand side, there has to be oxygen on the right hand side. There cannot be fluorine if there's no fluorine on the left hand side. Nor they disappear. For example, the same example, if there is oxygen on the left hand side, then there has to be some oxygen atom on the right hand side. We cannot avoid oxygen. So what actually happens during chemical reactions? Why there is release of gas? Why there is change of temperature if there is no change of mass on anything? So actually what happens during chemical reactions, it is breaking and making of bonds between these atoms. The elements do not change, the atoms do not change, but there is change due to the breaking and making of bonds. For example, if we see burning of coal, coal is made up of carbon, and in process of burning, we add O2. That is oxygen present in the air. So when carbon is added to oxygen, it forms CO2. So this is a part of chemical reaction where simpler reactants were added to form a product. Carbon plus oxygen changing to CO2. Similarly, for making of water, what do we need in H2O molecule? Two hydrogen molecules, two hydrogen atoms, and one oxygen atom. So on combining, they'll give H2O. So one atom of oxygen combines with two atoms of hydrogen to give two molecules of water. 2H2 plus O2 changing to 2H2O. This we got by balancing the chemical equation. So what are these reactions example of? These are example of combination reaction, where two simpler reactants reacted to form a complex product. So a chemical reaction in which two or more reactants combine to form a single product, where many reactants combine to form single product. For example, H2 plus O2 combine to form H2O. Now we'll see some examples. We'll take calcium oxide as one reactant and water as other reactant. We'll add them. There will be increase of temperature, and what will be formed? Slaked lime, that is calcium hydroxide. We had two reactants, calcium oxide, that is quicklime, plus water, and it changed into calcium hydroxide or slaked lime. So this is example of combination reaction where two reactants combined to form single product. Here if we see this slaked lime is used to whitewash the walls. This calcium hydroxide further reacts with carbon dioxide in the air. That's why we see that after a few days, the whitewash done on the walls, it changes into shiny color, shiny white color because of formation of calcium carbonate. That is calcium hydroxide combines with carbon dioxide to form calcium carbonate plus water. Now we'll see another type of reaction, that is exothermic reaction. We can remember this reaction from its name itself, exo, that is exit of heat. So these are the reactions in which there is release of energy or heat energy. For example, burning of natural gas. We have methane, which is natural gas. It reacts with oxygen to give carbon dioxide plus water. Plus heat energy is released. So this is example of exothermic reaction. So methane can be used to gain heat energy. Burning of natural gas methane in presence of oxygen to give carbon dioxide and water, and there was release of heat. So this is example of exothermic reaction. Reactions in which heat is released along with formation of products is example of exothermic chemical reaction. Another example is respiration reaction, where we burn where sugar. What is present in the food we intake? It is sugar, for example. It combines with oxygen that we inhaled and give out CO2 to the atmosphere plus water, and some energy is released that is consumed by our body. That is the food we gained, the food we ate, we use that to produce energy and release CO2. So this is also example of exothermic reaction where heat energy or any kind of energy is released. That is, there is release of energy in this reaction. Hence, it is example of exothermic reaction. We'll balance this chemical equation. The decomposition of vegetable matter into compost is also example of exothermic reaction. The vegetable waste we collect and then we keep it to turn into compost. So there is release of heat or there is release of energy in this reaction also. Hence it is called exothermic reaction. Next we'll study endothermic reaction. Endothermic reaction is opposite of exothermic reaction. What was happening in exothermic reaction? There was release of energy. But in endothermic reaction, we will provide energy to the reactants to convert into products. For example, we'll take sulfur as reactant along with iron, and then we'll provide heat. We are using burner, that is we are providing heat energy. It will change into product iron sulfide. That is iron plus sulfur changing into iron sulfide, but we also added heat in the to the reactants. So this is example of endothermic reaction. So the reaction in which heat is absorbed are called endothermic chemical reactions. Next, we'll study decomposition reaction. For example, AB changing into A plus B. Here the reactant AB got decomposed into simpler compounds A and B. A chemical reaction in which a compound, for example here AB, is split into two or more simple substances. This is example of decomposition reaction. So if we'll compare it with combination reaction, it is opposite to that. In combination reaction, two reactants combined to give a complex product. But in decomposition reaction, what is happening? AB, a compound, is broken into simpler products A and B. The decomposition reaction can take place under three conditions. That is, there are three conditions which can break a reactant into simpler compounds. For example, under heat, under light energy, or under electricity. Now we'll study them one by one. For example, we'll take calcium carbonate and we'll heat it. On burning, it produces carbon dioxide. So this carbon dioxide passes through this tube and gets added to the calcium hydroxide and turns it into milky. So calcium carbonate, on heating, we had one reactant, calcium carbonate. We heated it, it changed into calcium oxide, and the CO2 gas was released. How do we check that the CO2 gas was released? It was made to pass through this pipe and add to the calcium hydroxide solution, and it turned it milky. Now another example of decomposition reaction is heating of ferrous sulfate. We took ferrous sulfate. This is green color. We heated the ferrous sulfate and we observed that it has turned into colorless FeSO4. So the ferrous sulfate contained FeSO4.7H2O, that is 7 molecules of water along with FeSO4. When it was heated, it decomposed into FeSO4, which was colorless, plus water was released in the form of gas, that is water vapors. It is also advised that you never point this mouth of the test tube towards any person or even towards yourself, because there can be sometimes some harmful gases, or there can be bubbling, or the solution can come out due to strong heating. Okay. So always keep it in a safe direction where it never points to anyone. So the reaction that is taking place is FeSO4 in presence of heat changes to Fe2O3, that is ferrous oxide, plus SO2 plus SO3. So this ferrous sulfate is heated and it decomposed into Fe2O3 plus SO2 plus SO3. So these two gases are released. So a complex reactant changed into simpler substances. So this is also example of decomposition reaction. Similarly, we'll heat lead nitrate. It will lead to release of this gas and formation of product. So what has happened? These brown fumes, this indicates release of nitrogen oxide gas. So in this decomposition reaction, what happened? Lead nitrate was heated and it decomposed into lead oxide plus NO2 plus oxygen. So these brown fumes were due to this nitrogen dioxide gas. Lead oxide has formed and NO2 plus O2. So these are the products formed on decomposition of lead nitrate in presence of heat. Always remember to balance the chemical equation. So these were all examples of decomposition in presence of heating. So the decomposition reaction which were carried out by heating are known as thermal decomposition reaction. Next example, we take sugar and we'll heat it. So it will lead to formation of carbon. The sugar has converted into carbon and there is release of vapors, that is H2. We'll balance the chemical equation. So this is also example of decomposition reaction. In the product, if we write this arrow with the compound, this indicates that it is in form of gas and gas has evolved. So we can conclude that the reaction, the decomposition reaction which takes place in presence of heating is called thermal decomposition reaction. Example of heating of calcium carbonate, heating of ferrous sulfate, heating of lead nitrate, and heating of sugar. So these all were an example of thermal decomposition reaction. That is, the reactant changes into products, or the reactants decomposed into simpler products in presence of heating. Next, we'll study the decomposition in presence of light. For example, we'll take silver bromide. In presence of light, it will get decomposed into silver plus bromide. The AgBr reactant decomposed into simpler products Ag plus Br2. Similarly, AgCl in presence of sunlight changes into Ag plus Cl2, that is silver plus chloride. So this reaction where decomposition is happening in presence of light or due to light is example of photolysis. So the decomposition due to heat was thermal decomposition reaction, but the decomposition due to light is photolysis. Now both these reactions are used in black and white photography during the process of developing. So this is application of photolysis. Now we'll study decomposition reaction in presence of electricity. We'll take this reaction setup where we have added water into this plastic mug and we have connected it through electricity. We have two cathode and anode. And these cathode and anode are of graphite rod. These are electrodes. Then we'll add dilute sulfuric acid to the water. So what is the use of this acidified water? It will produce some ions which will help in conduct of electricity. When electricity is passed through this solution, the water gets decomposed into H2 plus O2. So this is an example of decomposition reaction which is happening in presence of electricity. H2O changing into H2 plus O2 will balance the chemical equation. So this decomposition in presence of electricity is no example of electrolysis. So this decomposition is known as electrolysis. So we have studied three, that is thermal decomposition reaction, photolysis in presence of light, and electrolysis, decomposition due to electricity. This process of electrolysis is used for extraction of metals like sodium or aluminium electroplating. Now, first of all, to study further types of reaction, we have to know the reactivity series of the metals. That is, which metal is more reactive than other metal. For example, we have this series from potassium, sodium, calcium to silver and gold, where downwards the reactivity is decreasing. That is, potassium is the most reactive metal here and gold is the least reactive metal. So the arrangement of metal in the increasing or decreasing order of reactivity, you can arrange it from least to most also, but we have arranged from most reactive to least reactive metal. So this arrangement of metal in increasing or decreasing order of their reactivity is known as the reactivity series of metals. Another example is displacement. Another type of reaction is displacement reaction. For example, AB plus C changing into A plus BC. If we see here, C displaced A and combined with B. C displaced A and combined with B and formed CB, and A was left alone. So C is the more reactive element and A is the less reactive element. So C removed A and combined with B. So a reaction where a more reactive element removes another element having less reactivity from its compound. That is, C removed AB from its compound, A from the AB compound and combined with B. So these reactions are termed as displacement reaction. So we'll see these examples. We'll take copper sulfate solution. What is present in copper sulfate solution? Copper and sulfate ions. Then we added this iron nail into this copper sulfate solution. After 20 minutes, we'll see that the solution has turned into green and the copper nail is plated with copper. What we observe that this green color is due to ferrous sulfate. That is, the copper sulfate solution now has turned into ferrous sulfate solution and there is copper on the iron nail. So what reaction has taken place? There was copper sulfate solution initially. It combined with iron nail. There was iron in the nail and then it gives rise to this ferrous sulfate solution and copper on the nail. So what has happened? The more reactive metal displaced the less reactive metal from its compound to form FeSO4 and copper. So we will see this reactivity series. In this, if we'll see copper and iron. Copper and iron. Iron is more reactive than copper. That's why iron replaced copper. If we see Zn plus CuSO4, if we see in this, Zn is more reactive than copper. So Zn will displace copper and form ZnSO4, that is zinc sulfate plus copper. So zinc has displaced copper. Another example, if we'll see lead plus CuCl2, that is copper chloride, Here if we see lead and copper, lead is more reactive than copper. Therefore, lead can displace copper and form lead chloride. So lead displaced copper and formed lead chloride because lead is more reactive than copper. Next, we'll study double displacement reaction. In the previous reaction, that is displacement reaction, only one metal was displacing the other metal from its compound. Here, both the metals will displace each other. For example, there is compound AB, where A is A plus and B minus. These are the ions of the compound. Then CD changing into AD plus CB. So here, B will displace D and will combine with C. B minus and C plus will combine to form CB, where A will displace C and form compound with AD. So it will form AD. So there is double displacement happening. So the reactants with a precipitate is formed by exchange of ions. So there is exchange of ions taking place. That is A plus was with B minus. Now it is with D minus. While C plus was with B minus, but now it is with C plus was with D minus and now it is with B minus. Therefore, there is exchange of ions. So reaction in which precipitate is formed by exchange of ions between the reactants is example of double displacement reaction. So in double displacement reaction, we'll see a precipitate is formed. Precipitate is this insoluble substance. This solid substance is formed and the reaction which produces a precipitate is called as precipitation reaction. Now we'll see some example. We'll take two solution, barium chloride and sodium sulfate, and we'll add both of them to each other, and then we'll see that we got barium sulfate as this white precipitate along with sodium chloride in the solution. So Na plus SO4 2 minus combined with barium 2 plus plus Cl minus. Now barium plus was with Cl minus, but in double displacement reaction, what happens? There is exchange of ions. Ba2 plus will now combine with sulfate, that is SO4 2 minus, and it will form barium sulfate. Sodium plus will combine with chloride and will form sodium chloride. So there has taken place double displacement reaction. So, and there's formation of barium sulfate precipitate. So this is a double displacement reaction, or we can also say precipitation reaction. Another example can be barium sulfide reacting with zinc sulfate, changing into barium sulfate with zinc sulfide. This downward arrow indicates that a precipitate is formed. For upward arrow, it indicates that there is evolution of gas. But the downward arrow indicates that is that is any precipitate is formed. So in this double displacement reaction, barium 2 plus combines with sulfate and zinc 2 plus combines with sulfide and forms zinc sulfide and barium sulfate. Similarly, copper chloride reacts with potassium iodide. There is exchange of ions and form cupric iodide, which is a brown precipitate indicated by downward arrow, plus potassium chloride. So these are examples of double displacement reaction. Always remember to balance the chemical equation. Next, we'll study oxidation and reduction reactions. First of all, oxidation reaction. As the name suggests, oxidation, that is, we are adding oxygen. Now we'll see, take an example. We'll take copper powder and we'll heat it. If we are taking copper powder and we're heating it, that is, it is combining with oxygen present in the atmosphere to give copper oxide. So what has happened? Addition of oxygen to the copper to form copper oxide. So this is example of oxidation reaction because copper is gaining oxygen. Now in this reaction, if we see, This is ethyl alcohol, and this is sodium ethoxide. There's removal of hydrogen. That is, hydrogen gas is removed from ethyl alcohol. So what has taken place? Oxidation reaction, because there is loss of hydrogen. So if we have to identify that what type of reaction is taking place for oxidation reaction, it is either addition of oxygen or loss of hydrogen. So in both cases, it is oxidation. So oxidation can be gain of oxygen or loss of hydrogen. Now reduction reaction, it is opposite of oxidation reaction. What was happening in oxidation reaction, if you remember? It was addition of oxygen and removal of hydrogen. But what happens in reduction reaction? Removal of oxygen and addition of hydrogen. For example, to carbon, we added H2 to give CH4 plus. So what happens in carbon plus hydrogen? That is, we are adding hydrogen, and addition of hydrogen is example of reduction reaction. Similarly, in ozone, there is O3 molecule. It gives rise to O2 plus oxygen. That is, we removed one oxygen from this ozone molecule to form oxygen. So there is loss of oxygen in this reaction, and loss of oxygen is also reduction reaction. So reduction reaction is an example where there is loss of oxygen or gain of hydrogen. So the chemical reaction in which there is loss of oxygen or gain of hydrogen is an example of reduction reaction. Next, we'll study redox reaction. That is, both oxidation and reduction are taking place in the same chemical reaction at same time, that is simultaneously. If we'll see, explain it with the example. If in this we'll see this CuO, it gives rise to only copper. That is, there is removal of oxygen, and removal of oxygen is reduction. But if we'll see in this hydrogen to water molecule, we see that there is addition of oxygen, and addition of oxygen is oxidation. Here, oxygen lost, that's why reduction, and here oxygen gained, that's why oxidation reaction. So copper oxide changing to copper is an example of reduction reaction, because copper oxide is reduced to copper. While hydrogen changing to H2O is an example of oxidation reaction, because hydrogen is oxidized to H2O. If we see that copper oxide is the one that gave its oxygen, that is, it is providing oxygen, hence it is called oxidizing agent. So the substance which gives oxygen for oxidation is known as oxidizing agent. The substance which gives oxygen for oxidation is called oxidizing agent. Here the example was copper oxide. Now the substance which removes oxygen is called reducing agent. H2 removed oxygen from copper oxide to form H2O. Hence it is reducing agent. In this example, try to identify whether oxidation is taking place or reduction is taking place, which one is a reducing agent and which one is oxidizing agent. For example, in barium sulfate, BaSO4, it changes to barium sulfide. Here we see oxygen is present, here we see there is no oxygen. That's why there is removal of oxygen. So this is example of reduction reaction. Now similarly in this 4 carbon changing into 4 CO. With this carbon there was no oxygen, but in the product we have oxygen with the carbon. That is, there is addition of oxygen, and this addition of oxygen is known as oxidation. Now the compound which loses its oxygen is called oxidizing agent, and the compound which gains this oxygen or that removes the oxygen is known as reducing agent. So barium sulfate is the oxidizing agent and carbon is the reducing agent. Similarly, if we'll go for zinc oxide plus carbon changing into zinc plus carbon monoxide, here we'll see that oxygen is lost from ZnO to Zn. It will be a reduction reaction because there is losing of oxygen. From carbon to carbon monoxide, there is addition of oxygen. That's why it is an example of oxidation reaction. Zinc oxide is the oxidizing agent because it is the one which gives oxygen for oxidation, while carbon is the one which took away the oxygen. That's why it is reducing agent. Another example, manganese oxide plus HCl changing into manganese chloride plus H2O plus Cl2. If we'll see that manganese oxide changing into manganese chloride, there is removal of oxygen. That's why reduction reaction. From HCl to H2O, there is addition of oxygen. That's why oxidation reaction. MnO2 is the oxidizing agent and HCl is the reducing agent. It must be clear that why MnO2 is oxidizing and HCl is reducing agent. Yes. Now we'll study another type of reaction. For example, if we see, we buy nails, new nails, but over the time, they turn into this form, where there is this reddish brown color on them. So what is this process? This is known as corrosion. The process of decay of metal due to effect of air, moisture, or acid is known as corrosion. These nails, when exposed to air, we have the atmosphere, and atmosphere contains air, moisture, acids. They all act upon this nail to corrode it and turn into this. So the effect of moisture turns this nail into reddish brown. This reddish brown gets deposited over these nails, and this is known as rust. That is, when iron, these nails were composed of iron, they combined with oxygen in the air and water in the air to form this. This is rust and this is reddish brown color. Similarly, if we'll see copper objects, we buy them new. With time, they convert into this green color. There is this green color layer due to reaction of copper with moisture and carbon dioxide. So this is also example of corrosion. So the green substance formed, this green substance is formed due to reaction of the copper with carbon dioxide and moisture in the atmosphere. If we buy a new silver coin, but with time it changes into black. Why is this happening? Because the silver is reacting with hydrogen sulfide, which is present in the atmosphere, and form the black color. Now, for example, we keep the food for a long time. Can we keep the food for a long time? No, it gets spoiled. The food we cook, it gets spoiled after some time and it starts smelling. Why does this happen? The reason is rancidity. The oils and fats, we use all of this when we cook our food, we use oil. They get oxidized when they are allowed to stand for long time. That is, they become rancid. So, this change in taste and change in smell of the food is due to rancidity. But if we see, we buy some food like the chips packets. The chips we buy, they can be stored for a long time. If they are in the packet, they can be stored for a long time. So how do we prevent this chips from spoiling, from rancidity? So there are some ways in which we can prevent the food from spoiling and we can store it for long time. For example, the chips packet being contained in chips packets which is stored with nitrogen. Nitrogen is a inert gas. It is not like oxygen or water or moisture present in the air which will spoil the chips. Instead, nitrogen will not react with chips and it will keep the chips safe. Another method can be antioxidants. What is rancidity? It is oxidation of the fats and oils present in the food. So to prevent that oxidation, we'll add some antioxidants to the food. Food also can be stored in refrigerator because in refrigerator, the temperature is very low. Low temperature slows down the reaction and hence Rancidity also slows and the food can be stored for longer time. Similarly, if we keep the food away from the sunlight, it also prevents the decay of food because sunlight can increase rate of rancidity. But if we keep away the food from sunlight, it will help the food be safe. So the methods to prevent rancidity can be keeping the food in airtight container, or for example storing it with nitrogen, using antioxidants in the food, storing the food in refrigerator, or keeping the food away from sunlight. So now we have today we discussed, what do we discuss today? We started with chemical reactions. We saw different chemical reactions. For example, milk turning into curd, fermentation, cooking of food, respiration. So all these were type of chemical reaction where was some reactant was changing into product. Then we saw some examples. For example, the formation of yellow precipitate, or whether it was this release of hydrogen gas when we added zinc granules to the dilute H2SO4. So all of this showed us that what can happen during a chemical reaction. There can be change in state, change in color, there can be evolution of gas, there can be change in temperature, and this can be formation of precipitate. Then we saw the valency chart, that which elements have what valency. There's one valency for these, two valency for these. Aluminium has a fixed valency of 3. Copper has variable valency, that is +1 and +2. Iron has a variable valency, that is 2 and 3. For chemical equations, we see how can we write chemical equation, where we write reactants on the left hand side, products on the right hand side, and separated by arrow. If there are more than one reactant, we'll separate them by plus sign. We'll write a chemical reaction in form of symbols. And then we studied about balancing of chemical reactions. Why do we need to balance the chemical equation? Because we have to follow the law of conservation of mass, where mass can neither be created nor be destroyed, and the total mass of elements in the reactants has to be equal to mass of elements in the products. Then we saw stepwise balancing of the chemical reaction, where we wrote elements and their number of atoms on the left hand side and right hand side, and accordingly we multiplied with the required number to balance the chemical equation. We started from the compound which had maximum number of atoms for balancing. Then we also saw that we can write the states, that is whether the reactant or product are solid, gaseous or liquid, in the small brackets. We can also put these reaction conditions on the arrow. Then we studied types of chemical reactions. For example, the combination reaction, where two or more reactants combine to give single product. We saw some examples like addition of water to quicklime to give slaked lime. Then we studied endothermic reaction, where there was release of heat along with the formation of products. Then we saw some example, for example, respiration reaction. Then endothermic reaction was another type of chemical reaction where there was heat is absorbed during the reaction. So it is opposite of exothermic reaction. Next we saw decomposition reaction. It is opposite of combination reaction, where reactant got decomposed into simpler substances. It can happen under three conditions, that is heat, light and electricity. Under heat it was called thermal decomposition reaction. Under light it was called photolysis. Under electricity it was called electrolysis. Then we saw some example, that thermal decomposition of calcium carbonate, ferrous sulfate, or lead nitrate, or sugar. These were all example of thermal decomposition reaction. Then we studied photolysis. For example, photolysis of silver chloride, gives rise to silver plus chloride, that is decomposition due to light. Then we studied decomposition due to electricity, that was called electrolysis, H2O decomposing into hydrogen and oxygen. Next we studied reactivity series of metals and then we studied displacement reaction, when a more reactive element was displacing a less reactive element from its compound. Then we saw a few examples of this displacement reaction. Next, we studied double displacement reaction, where there was exchange of ions between the products. Exchange of ion between the reactants to give these products. Then we saw a few examples of double displacement reaction. This downward arrow indicated formation of precipitate, and hence these were also called precipitation reaction. Next, we studied oxidation and reduction reaction. Oxidation is either gain of electron or loss of hydrogen. Then redox reaction, where redox reaction is either loss, in redox reaction we studied that both oxidation and reduction are taking place simultaneously. And we studied the concept of oxidizing agent, the substance which gives oxygen for oxidation, and then reducing agent, the substance which removes oxygen. We saw a few examples. Then we studied about corrosion, that how the air, moisture, acid present in the atmosphere decay the metal. We study example of rusting. Then for copper, the blackening of silver. Next we studied rancidity, that is the oxidation of oil and fats present in the food. Then we studied some ways to prevent rancidity, that is by keeping the food in airtight container or using nitrogen, antioxidants use, storing in the refrigerator, or keeping the food away from sunlight. So today we have discussed all of this. Thank you for joining. See you in the next class. Goodbye.